Good day, everyone. I welcome you to another episode of Chemistry Simplified with Gido Academy. And in this particular video, I will be explaining standard separation techniques, which is crystallization and fractional crystallization. This is actually a part of chemistry that most students don't even understand, but it is very, very important you understand what crystallization is all about and what fractional crystallization is all about. So, crystallization is used to obtain solid solutes from a solution by heating to evaporation the solute and then allowing the remaining saturated solution to do what? To cool off. Let me explain what this statement means. Now, what is a saturated solution? Let's say this is a beaker and this beaker contains hot water. If I keep on dropping salt and then stirring, keep on dropping salt and stirring, keep on dropping salt and stirring, what's happening is that the salt is going to dissolve. If you get to a stage whereby the salt can no longer dissolve, that situation is called what? Like you can't dissolve more salt in it. I don't know if you understand what I just mean now. Now, if I keep on dropping salt in this situation, in this container, in this hot water, it will be dissolving. If you put salt in water, the salt is going to dissolve now. Yes. Now, if you keep on adding salt, it will get to a stage whereby that salt can no longer dissolve. So we call that a saturated what? Solution. Now, let me come back a bit. Let's say you added this is the impure salt that is inside. Emphasis on impure salt. That's inside. Let's say impure sodium chloride. That's the salt that is inside, which is a normal table salt, and it is what? Impure, which is not pure. So it is not a saturated solution now. It is unsaturated, which is you can still add more salt to it. So it is called unsaturated solution. If you should heat this, the solvent is going to evaporate. What I mean by solvent is the water is going to evaporate. The hot water is going to evaporate once you heat. But it will get to a stage whereby you will know that this solution is saturated. I've explained what saturation means. So you stop the heat. You allow the water to cool off. When it cools, you are going to form what? Crystals, salt crystals. And the salt crystal you will get will be of what? Sodium chloride. And the sodium chloride will be what? Pure instead of impure. Because there is a difference in solubility between the impurity that is inside and what? The sodium chloride that is present. So you filter out your salt crystal, and the whole process is called what? Crystallization. But for fractional crystallization, it's quite different. Instead of you to have impurity and salt, you are going to have two solutes. And instead of you to have one solute and one impurity, you are going to have two solutes. Let's say, for example, KNO3 and potassium chloride. Let's say these are the two salts that are inside, no impurity. Now, what will happen here is that for fractional crystallization, the pure component of the mixture based on their solubility at various temperatures. The solubility of this one differs from this one. So once it is heated, they are still going to form the same pattern, still going to form crystal. You will now filter it out. But the major difference is that there is difference in solubility, and this one is what? They have a different solubility. But for crystallization, the solubility is between impure substance and what? And the salt. Let's look at the difference again. The crystallization is talking about purification of salts. The salt is impure. We are trying to purify the salt. But for fractional crystallization, it's not talking about purification. It's talking about separation of two salts that are dissolved in what? In solutes. Sorry, in solvent. Two solutes dissolved in solvent. But these two solutes, they have what? Different solubility. Why for this one? The solute plus the impurity, they have different solubility. But this one consists of two or more what? Or more solute. And lastly, the solubility is usually between the solute and the impurity, while the solubility of fractional crystallization is between the two or more what? Or more solute. So if you see a question like this in the exam and you are seeing two salts dissolve in water, your mind will always go to what? Fractional crystallization. But if you are talking about an impure salt, and impure entity, just here impure salt, impure sugar, your mind will always go to what? Crystallization. If you have two salts or two sugar or one salt and one sugar, as long as there is difference in their solubility at different temperature, your mind will always go to what? Fractional crystallization. So crystallization is all about an impure salt and an impure solute. impure solute. Impure solute. Yeah. Why this is usually between solutes, which can be salt plus what? Plus sugar, or salt plus salt, or sugar plus what? Plus sugar. But at the end of the whole thing, they have different solubility. It is used for separation of solute in solvent. So this is what you use fractional crystallization for. If you have any question regarding what I've explained so far, remember, I don't want to teach you what you don't need. I want to teach you what you need for your exam. I want to simplify chemistry for you, so that in case if you see a question like this, no matter how they try to twist the grammar, you always know that Sir Gideon said, or Gido Academy have already pushed it out to us, that fractional crystallization is between two solutes in water in terms of separation, while crystallization is for solutes and what? And impurity. Thanks for watching. If you like what I do, why not smash the subscribe button, share the videos to your friends, share it to those who are writing Waec and Jamb. Our goal still remain simplify chemistry for Waec and Jamb exam. Thanks for watching. Stay blessed.